Have you ever wondered how does an enemy know where to chase you or how a bullet just flies straight to where your mouse is pointing? No, it's not magic. It's vector math. Wait, don't run. I promise. This won't give you high school flashbacks. This is the secret sauce behind so many cool game mechanics. And hey, I'm not some mad genius either. You don't have to be. You just need to get one simple idea: direction, distance, and movement. That's basically what vectors are all about. Okay, imagine you're standing somewhere in your game world and you want to go somewhere else. Draw an arrow from where you are to where you want to be. Boom, that's a vector. If you want the fancy definition, a vector is just a set of numbers, like two numbers in 2D or three in 3D, that tells you two things: direction, where the arrow points; magnitude, how long the arrow is. Let's say a player is standing at origin. So 1 0 points to the right and 0 minus 1 points down. But what about 3 4? That points diagonally upright and it's longer because it's moving more. In most game engines like Godot or Unity, we use something called Vector 2 for 2D space and Vector 3 for 3D. Even positions are stored using vectors, like the position of a sprite, that's a vector. Wanna move right? Just add 1 0 to its position. Wanna move left? Just add minus 1 0. Do the same for other directions, and guess what? If you hook those to your keyboard keys, you've got a basic movement. Now let's level up. Say your enemy is chilling at 2-2 and the player is at 10-10. How does the enemy know where to go? Well, subtract the enemy's position from the player's. That gives you a direction from enemy to player. But if you add the vector straight to the enemy's position, it will teleport. We don't want teleportation, just smooth chasing. So what do? We normalize the vector. That means we first calculate the magnitude, which means the length, and then create a normalized vector, one that keeps the direction but has a magnitude of 1. Now, if we add that normalized vector to the enemy's position every frame, it moves smoothly toward the player, one unit at a time. Thankfully, you don't have to remember all the formulas. Most game engines have a built in normalize function, and just like that, your enemy starts chasing the player. No pathfinding yet, just pure vector math. But wait, there's more. Let's talk about the dot product. Sounds scary, but it's just a way to tell how similar two directions are. If the dot product is 1, they are pointing the same way. If it's 0, they are at 90-degree angle. If it's minus 1, they are pointing in opposite directions. So, if you ever want to check, is the player facing the enemy or is the object looking where it's going? Dot product is your answer. Here's the formula to calculate the dot product of two vectors. But again, you don't have to crunch number yourselves. Just use dot function with two vectors and you are done. Let's take this into a real game example. Let's say you want to check if the player is facing the enemy. And for that, I have a simple code that checks the dot product between the player and an enemy. If the player is facing toward the enemy, we change the sprite color to green, meaning the dot value is greater than zero point 0.9. If they are facing opposite direction, we make it red. Same thing goes for the enemy. Now, we see both sprites are green because they are facing each other and their dot product is close to 1. But if I rotate the player's sprite to face away, it turns red, while the enemy is still green. Now, you might think, wait, aren't they both facing right? Shouldn't they both be green? That confused me too at first. But we are not comparing their facing directions. We are comparing the direction they need to move to reach other with their current facing direction. For the player, I calculate the direction vector from the player to the enemy like we did earlier. Then I take the dot product of that direction vector and the player's current facing vector. Same logic applies to the enemy. If you are curious and want to go deeper, check out 3 blue 1 browns video on vectors and dot products. So that's a basic vector math. Not so scary, right? Learn it once and you will start seeing it everywhere.